Hi, I'm Justin Stovich, and I'm the Associate Product Manager for Instrumentation Products here at Turk. And today I'm going to be talking to you about our newest product, the DR15S Distance Radar Sensor. The DR15S is made for rugged industrial applications for both distance and level measurement. It comes with an IP69K rating and comes in an M30 barrel style body. This sensor comes in two different configurations, in both an analog output configuration and a purely switching output configuration. And today we're going to go over a simple application to kind of just show you how to parameterize and configure this sensor using our Turk Automation Suite software and IO-Link. So let's get to it. To start off, first you will need the necessary products. You will need the distance radar sensor, a cable, and a Turk IO-Link master. Now, it is a requirement that you need a Turk IO-Link master to get all of the features available for you to use in IO-Link and with our Automation Suite software. So let's get to it. So first we will open up Turk Automation Suite. Okay, once in the Automation Suite, you want to scan your network and find your Turk field bus device that is connected to it. As you can see, it can see this TBEN S24 IOL. And from here, we will go to the website in TOS, where we can parameterize the device, the block, and our distance radar sensor. Okay. Now, once we are into the device website, we need to log in. And once logged in, we can go to the IO-Link section. And you can see that the IO-Link master recognizes that there is an IO-Link sensor connected to it. It sees that's the DR15S, but it doesn't know what parameters to parameterize it with, so it needs an IODD file to allow that communication. So we'll do that easily by clicking on the web search option. And there you go, it has found our IODD file that we need to parameterize and configure this sensor. Okay, once here, in our website, we can go through all these options here. We can look at all the parameters that we can parameterize using this IODD file on the website. And here are just some of the parameters that you can see. Today we are actually using the analog output module or sensor. So this guy comes with both an analog output and a switching output, but also the analog output can be configured to another switching output. So this could be a purely switching output device. And we'll go through, here's just diagnosis, gives us device status, device is okay, that is good. Our observations of signal strength and whether or not we're in a switching state or not. The process data that is being outputted to the block, our process data structure, how our pinouts and connections, event history, archive events. But here's what we want to show you today is the Turk radar monitor. Now, this is a visual representation of what the sensor is currently seeing to help you configure and parameterize the sensor for your application specifically. Now, as you can see, on the x-axis here, you have the distance that the sensor is recognizing or can see, and that is from a range of 0 to 15,000 millimeters, or the range is 350 millimeters to 15 meters. And then on the y-axis you have the signal strength, and that is how strong the target is reflecting back the electromagnetic waves to the sensor itself. And that is kind of based on the dielectric constant and the angle at which the target is facing the sensor itself. Now, when you are here in the Turk radar monitor, you can see this red line here, but you also see these little blue T guys here. Now these are data sets, and each one of these blue T's represent an object that the sensor recognizes. On off screen, I have a metal pail, I have a cardboard box, and then a wall behind these two objects, and that is what the sensor is currently seeing right now. Now we're going to utilize these measurement-specific parameters and filter modes to narrow in on one of these objects, and we're going to choose the cardboard box. And to do that, we're going to first amplify the signal that is coming back. We will turn that to high, just because a signal of 6.3% isn't that high. So now that we turn the signal amplification up to high, usually when you do that, that just doubles the amount of signal strength that is coming back. When you go to low, it halves it. Okay, so now we want to filter out the wall. We don't want to see anything beyond the cardboard box, and I can see that the wall is here at 27, the cardboard box about 22, just under. So we're going to use the background suppression to filter out anything beyond 2200 millimeters. Okay, now you can visually see that the sensor is no longer recognizing objects beyond 2200 millimeters. So next, we're going to have to filter out this metal pail. Now we can do that one of two ways. We can use the foreground suppression, kind of the same way we just did, by filtering out, let's say, anything beyond 1500 millimeters, or filtering anything before 1500 millimeters. Or we can use the signal amplitude filter mode, and that's what we're going to do. We're going to do a max amplitude filter. Okay, so we can see the box is going back about 13%, and the metal pail is doing about 28. So let's have our max signal filter be 20%. So anything beyond 20%, this sensor will not recognize it as an object. Okay, there we go. As you can see, it only recognizes one of these spikes as an object, and we can kind of see that represented here in the observation tab as well. As you can see, it is in a switching output state, and its signal strength is 12.7%. Now, this sensor, the first object that it recognizes will be the object that it puts into a switching state. So if I were to get rid of the max filter, like so, you can see here that the metal pail is at 28%. If we go to the observation tab, you will see that, yes, there's something that the sensor recognizes, so it's in a switching state, and that signal strength is 28%. Now this doesn't matter, even if we got rid of the, background suppression and the wall, which has a higher signal percentage than both these objects. It will still recognize the first object it sees as the switching output object. See, there you go. Even though the wall is over 100% amplitude, it still is not the object that is causing this sensor to be into a switching state. And lastly, the filter that we didn't really touch on is the raw data filter PT1. Now, this is only going to be utilized when you have turbulent surfaces. So let's say you have a tank that is currently filling with water, or there's a mixer in there that is agitating the water. You can use this raw data filter to kind of smooth out the data that is initially coming in, so that you don't get all these random data spikes. It kind of just smooths everything out and gets you a more level output for applications like that. And that's how you utilize the Turk Automation Suite software in the Turk radar monitor to parameterize and configure this distance radar sensor. If you have any questions, please contact our application support, and many thanks for your attention.